right, so what do we have in our previous knowledge bank? Jonathan, what'd you get for number 1? Parallel, very good. So those 2 bars right there mean parallel. That's the notation for parallel. It's not the picture, it's the notation like when you're writing in a sentence. Raquan, what'd you get for number 2? Oh, sorry, I'm still getting to know. Number 2, good guess, try again. So we already used this one. It's not ray. Yes, very good. That is the symbol for congruent. It's like an equal sign with a squiggly on top. Equal sign with a squiggly on top. Alejandro, number 3. Try again. Yeah, that's a ray. A ray has 1 arrow, and we're going to learn more about that today. And so by process of elimination, class, what's number 4? Perpendicular, that really long word that I'll let you write yourself. That is the symbol for perpendicular. It's an upside down T, and we'll go over perpendicular a lot more in the next unit. All right. So we already went over the answers yesterday. That first word is point. A point is simply a location in space. Does it have a thickness? No. Does it have size? No. It's just a location in space, and we'll learn more about how you create a point later. How do you name a point? How do you name a point? Capital letter. Lowercase letter? No, capital letter only. So yes, it does matter whether it's capital or lowercase. And so I would name this point P. If I were writing about that point, I would call it capital P. So in the notation part where it says notation, put a capital P. Point, notation, capital P. That's all you put, 1 big P. Use color. Make it pretty. Use that bold marker. Next word. Line. Now, this is your textbook's definition, which we'll talk about later in the textbook. I don't love the definition, but that's what it says, a connected straight path. So it's like a lot of points connected together. It doesn't have thickness, and it continues forever. There's no beginning, and there is no end. Forever, in both directions. What does both imply? Does it imply that it continues in like 5 directions? 1 direction? What do you hear? What do you think of when you hear both? 2. Very good. It goes on in 2 directions. How do you name a line? This is the notation right here. You put a capital letter with a line on top. So that's the notation. Write that in the notation box. That's the notation. Always right here is the notation right here. It's confusing because you can also name it with a lowercase italicized letter. So you can put both of these if you want, because there's 2 ways to name that line. You can call it line AB, or you can call it line L. There's 2 ways to name the line. Question? Okay. That's right there, that red thing. Okay. So A and B are points on the line. L, it's not a point on the line. It's just the name of the line. Let's keep going. Plane, point, line, plane. These are 3 main people. Point, line, and plane are main dudes. A plane is a bumpy surface? No, what is it? It's a flat surface. It's a flat surface. It has no thickness. It extends in both directions? No, it extends in all directions. So it is going everywhere, that flat surface. North, east, south, west, northwest, all of the above. You can name a plane 2 ways. One of the ways is you use 3 points on the plane. X, Y, Z, because I see dot X, dot Y, dot Z. Or you could name it by 1 capital italicized letter. Pretend this is italicized. A capital R. Okay? Are you writing this down like in the notation? Call it X, Y, Z. X, Y, Z. Or you could call it plain R. 2 ways to name it. So guys, this one's always the picture. That's already on your sheet. This one's always the notation, how you write it. 3 capital letters. Alrighty, a segment. A segment is when you take a line and you chop off the arrows. The arrows are gone. A segment does have a beginning and an end. They're called end points. So C and D are our end points. The notation is capital C, capital D, with a segment on top. Don't put arrows, because it's not a line. So good. Whew. There's only one way to name this one. That's good news. One way to name it. It is a portion of a line. So a segment has to come from a line. You have to have a line first, and then you can create a segment from that line. The line has to exist first, though. Next one. What do you think of when you hear ray? Stingray. Oh, like a stingray. Yeah. I think of like a ray, like a ray of light coming out of like a flashlight or the sun. It starts somewhere, but then it keeps going forever. When you shine a flashlight, that ray starts in your flashlight, and that light goes on forever, theoretically. Same with the sun. The sun is the end point, and then the rays come out forever. It has one end point, and then all the points are on one side of that end point. Notice capital F, capital G, with a ray on top. One arrow only. So that's the notation for a ray. All right, collinear points. We filled this in yesterday. There's no notation here, really. I know it just says A, B, and C are collinear, but there's really no notation, so if you want to leave that part blank, you can. I was just describing it. So collinear. Say that out loud. Say it. Collinear, because people were saying it wrong a lot yesterday. Like, I don't know what y'all were saying, but it did not sound like collinear. Think of a coworker. If I'm talking about my coworker, what does that mean about that person? Yeah, what is a coworker? What is a coworker? Works with you. Someone who works with you, like in the same building. My coworker is teaching across the hall right now. So collinear points mean they are on the same line. So that co kind of means same. And look, the word line is in here. Line. So it's points that are on the same line. So that's what collinear means. Same line. Collinear, same line. Co means same, linear means line. Coplanar would mean same. Oh, this is out of order, isn't it? Stop. Hold up. Nope, nope, don't do it, don't do it. We need non. Okay, I skipped non, but we filled these in yesterday. The next word was non-collinear. There's no notation, so I'm just going to move on. Non-collinear just means they're not on the same line. So collinear, same line. Non-collinear, not the same line. Okay, now we're on the back. Flip. Okay, so if collinear means same line, then coplanar means same plane. Awesome, thank you. Same plane. Coplanar. Same plane. So we're on the back now. Careful. We're on the back. Oh, goodness. We skipped opposite rays. I see. See, if you already would have had it, you would have the words filled in. We're on number 9 right now. Opposite rays we'll learn about on Friday. We're on number 9. So A, B, and C are coplanar because they are all on the same plane. The next word would be non-coplanar, but I don't have a slide for that because it's just the opposite of coplanar. So the next word, number 10, is non-coplanar. It just means points that are not on the same plane. And we will get much more into that in a minute. Okay. So I want you to take a look at this figure. And we're going to practice naming these things. Name line M another way. So have you located line M? We can name it by choosing how many points on the line. What does your note say? When you're naming a line, how many letters do you need? Awesome. 2 letters. So pick 2 points on that line. Awesome. So I could name it, instead of line M, kind of like in your notes, I could name it line AB. And you need to practice writing it correctly, because I will take off points if it's not written correctly. And you know what? There's no other way to name it unless we wanted to switch the letters. and name it line BA, because those would be the same exact line. Number 2, name the point that lies both on line N and line K. So, Alex, name the point that lies on line N and line K. Oh, so you're going to be Alejandro and he's going to be Alex to make it easy for a while, and if you want me to shorten it later, I can. Oh, it's right here. Name the point that lies on both N and K. Find line N, find line K. Good, very good. How do you name a point? What does it say on your notes? How do you name it? 1, capital letter. Awesome. So, we just put the capital letter E and we move on right along our merry way. Number 3, name the line that contains point A and point E. So, Seth, which line contains A and E? 2 lines do. Okay, but I want good, very good point. You're seeing stuff I don't see. I want the line. This one's tricky. I did this on purpose. Is there a line already drawn in that picture that contains A and E? Do you see it? It's not there. There is no line that contains A and E. But it does exist. So I do want to tell you, don't you? I see you shaking your head. Just because it's not drawn doesn't mean it doesn't exist. So yeah, there sure is a line, and I hope my alignment's, okay, there we go. There's a line. There it is right there. It wasn't in the picture before, but the line does exist. I can connect A to E. So let's name that line. How do you name a line? 2 capital letters with a line on top. So there we go. We just named the line that contains points A and back to your notes. What number is this? Let's make sure we're on the same number. Number 11, parallel lines. Parallel lines, it's important that they are in the same plane. I would underline that or highlight it with your marker. Parallel lines have to be in the same plane. Ooh, who can tell me what another word is for same plane? Raise your hand. We just went over it. We are on number 11. What's another word for same plane? Raise your hand. Come on. We just went over it. What?
No, forget it.
It's right above it. Coplanar. Very good. Same plane, coplanar. So parallel lines are coplanar lines that do not intersect. When I want to show that 2 lines are parallel, I'll just put an arrow on them, like is right here, but my alignment's off, so that made it uglier than it really was. So this is the notation. Put this for notation. The picture's already drawn. Don't worry about the picture. This is the notation. We did this in our warm-up. Cool. That was number 11. What observation can you make about the figure below? So look at that figure. This is different from algebra, isn't it? This is very different. What is line B doing? See line B? Are you looking at the figure? Why do you think right here that there's a dotted line? Why did the line go from straight to dotted? Okay. Very good conjecture. It's going through the plane. Very good. That line is piercing through the plane. So it's like I take a plane, and then my line is piercing through it, like going through the plane. So it's dotted because right now it's behind the plane. I just hit R, now I'm behind R, and now I came out from the bottom. So when you see a dotted line, that means that it's behind that figure. You can't see it, so that's why it's dotted, okay? So line B is intersecting plane R at point C. So here's some things we could have observed. Line B and line A, they're not coplanar. They're not in the same plane, right? Line A is in plane R, but line B is not in plane R because it's shooting through plane R. So that's important. Are line A and line B parallel? Are line A and line B parallel? Well, they're not intersecting, right? I'm trying to get mine. Just use 2 rulers. They're not intersecting. But there's a different word for that. So this is parallel right here. This is what they're doing, though. They're not intersecting, but they're not parallel. So there's a word for that. And that word is skew. There's no R in it. Yesterday people were trying to add an R that doesn't exist. Skew is how you say it. Skew lines. This might be new. Parallel, you've heard that before. You might not have heard skew before. So skew lines are lines that are not coplanar and do not intersect. The only word that's different from parallel and skew is the word not. Because parallel lines are coplanar lines that do not intersect. Skew lines are not coplanar lines that do not intersect. So literally, this is the only word that's different in the definition. One measly word. It changes a lot. So line A and line B are skew lines because they're not intersecting. All right. The next thing we're going to do, go. Plot that point. -5, 4. Plot it. -5, 4. So you're going backwards. 1, 2, 3, 4, 5. 1, 2, 3, 4. It said to call it A. So call it A. Capital A, that's how you name a point. Capital letter. Over 5, up 4. Backwards 5, up 4. Okay, we're going to draw a line through it, and we're going to call it line M. It says to use a straight edge. You can use the corner of your notes page, or you can just wing it, because I don't have a straight edge pulled up here. Draw any line in the whole world through point A. Any line you want. Don't match mine. Just draw a line through it and call it line M. So do a little cursive lowercase m by the arrow. Any line you want through A, but make sure it's a line. What would it need to be a line? You got it? What? Arrows. It's got to have arrows to be a line. Beautiful. Could you draw a line through that point for me and call it M, please? Draw a line. Y'all are being too picky. We're on the other side. Look over. We're on the left side. Compare your line with the students around you. Show your friends your line. Show them. Show them which one you drew. Some people chose to draw vertical. Some did horizontal. Some did diagonal lines. What do you notice? What do you notice about your line compared to your neighbor's lines? They're different. We all used point A. Do you agree we all had the same point A as long as we remembered how to plot points? Okay. But we all drew different lines. So I want you to make a conjecture. A conjecture is like a hypothesis. It's like a guess. There exists blank lines through a single point. What goes in that blank? Raise your hand. What? Infinite. I heard many, and that was an awesome conjecture. But the actual word is infinite. What does infinite mean? You can't use the word to describe the word. So infinite, you can't even name the number of possibilities. There exists an infinite, this is the symbol for infinity, an infinite number of lines through a single point. There doesn't exist 100, 200, 5,000, there exists an infinite number of lines through a single point. And we will formally write this down tomorrow, so don't worry about writing that down. Next thing, erase. Plot point B, 3, 5. 1, 2, 3. 1, 2, 3, 4, 5. Call it B. What does it say to do next? Oh, your marker's right here. You can open it by doing this. And you can plot. Reflect it over the y-axis. Oh my goodness, you know how to do that? Which one's the y-axis? Yes, so this is y and x. So I'm going to flip it. I'm going to reflect it over the y-axis. How far away is B from the y-axis? How many units?
3.
1, 2, 3. So just go the other way and go 3. 1, 2, 3. And it says to call it not B, because you can't call 2 points B. It says to call it B prime. B with a little tick mark. I call them tick marks. B prime. All right. Draw a line through point B and point B prime. Do it. I don't want to show you what it looks like. Draw a line through point B and point B prime. Oh, one line, not two lines. Good idea though. One line. I didn't think students would do that. That's not a line yet. That's a segment. Compare your line with the students around you. Show them your line. Show them. Show them your line. What do you notice this time? What do you notice? They're all the same. They're all the same. But you could say, well, mine was shorter than theirs. Can a line be shorter than another line if they go on forever? No. So all of your lines should have been exactly the same. So we can make another conjecture. There exists blank lines through any 2 points. How many lines? 1. Right? We all drew the same line. So if you have 1 point, you have infinite number of lines. But if you have 2 points, you only get 1 line out of that. A lot changes when you add another point to the picture. So that's really important. All right. Oh my goodness. Erase. You have some plotting to do. -2, -4. And I'm going to call it R. 7, 1. Call it S. -4, 6. I'm going to call it T. And 3, -3. And call it U. I'll give you some time to do that. So we're constructing line RS. So I'm going to take R, connect it to S. Make sure you put lines on it. Don't get lazy. And then connect T to U to get line TU. They intersect, right? So these are not parallel. They're not skewed because they intersect. What do you get at their intersection? What is that? Is it a point? Is it a line? Is it a plane? What is this right here? It's a point. You have all these. Name it. Name it whatever letter you want. Name that point. A, M, R, L. I don't care. Name it. Oh, we already have a T. I can't name a T. I'll do A for my first name later. So, when 2 lines cross, we're going to make a conjecture. Wait, I want to make a conjecture. There we go. If 2 lines intersect, then they intersect in exactly 1 point. So, when 2 lines cross, when 2 lines intersect, we get a point. And you named it whatever you want. But we get a point. Now, I want you on your board to draw 2 lines that intersect more than once. Draw 2 lines that intersect more than once. Two lines that intersect more than once. Show me. I love giving you impossible problems. Is it possible for 2 lines to intersect more than 1 time? No, because lines can't bend. So you're like, okay, I got this, Miss Tan. I can so do this. I'm going to prove you wrong. And you draw that and you're like, oh. And you try all different ways and you're like, well, once it hits him, it can never hit him again because you can't curve and go back, right? So if 2 lines are going to cross, they're only going to cross 1 time. They can't cross more than once. That is impossible. Okay? I think we got that point. We're going to skip this for today because we are running out of time. Yep. Okay. Are the following statements true or false? Any 2 points are collinear. So, John, draw 2 points on your grid. Any 2 points. 1, 2. Okay, John drew 2 points. Could Michelle draw a line through those 2 points? Could she do it? Absolutely. Now try to draw 2 points that Michelle could not draw a line through. Could you draw 2 points on your board where you gave it to me and I couldn't connect them with a line?
No.
No. So, true or false? Any 2 points in the universe are collinear, are on the same line. True. Very good. So I could have a point on Mars and a point on Jupiter, and someone could draw a line through them. Any 2 points in the universe are collinear. Any 3 points are collinear. True or false?
True.
Any 3 points you could draw a line through. Draw me a counterexample on your board. Show me it's false. Show me. Show me 3 points that I couldn't draw a line through. It's pretty easy, huh? Yeah. 1, 2, and then put it anywhere else, just not in a row. I can't draw one line and hit all 3 of those points. I can't. It's impossible. So this one was true, but this one was false. Okay. We're going to have to save some of these for tomorrow. This is our exit ticket. We just talk about this, and then I give you the assignment. And you get to work on that till the bell rings. Through, let's call it a name. Through any 1 point, there exists how many lines, Michelle? Infinite. Infinite. Good. Yet, through any blank points, there's exactly 1 line. How many points do you need to get 1 line? How many points? Okay. Charles? Not here, that's right. Richard? 2. Through any 2 points, there's exactly 1 line.